Good morning. In the previous classes, we have learnt about Arrhenius theory, Bronsted-Lowry acid-base theory. In this class, we are going to discuss Lewis acid-base theory. Okay, see. According to Lewis theory, an acid is defined as, already we discussed definition for acids according to Arrhenius and also according to Bronsted-Lowry. Okay, according to Arrhenius, which gives H plus ion in aqueous solution is acid. According to Bronsted-Lowry, proton donor is acid. How Lewis defined acid? According to Lewis, the substance which can accept a pair of electrons from other substance and form coordinate covalent bond, nothing but dative bond with it, is known as Lewis acid. Okay, we simply says electron pair acceptor is acid. Okay, example H plus, BF3, BCl3. These are the some examples of Lewis acids. How they are act as acids, we will discuss in the reactions. So finally, according to Lewis, electron pair acceptor is acid. Similarly, what is base? Reverse. Electron pair donor is base. Example, NaH3, H2O. Electron pair donor is base. According to Lewis theory, the substance which can donate a pair of electrons to the other substance and form coordinate covalent bond with it is known as base. Simply says electron pair donor is base, right? Example, formation of ammonia boron trifluoride. Formation of ammonia boron trifluoride. Okay, see. In the formation of ammonia boron trifluoride, there is a reaction between ammonia and boron trifluoride. Ammonia formula NaH3 and boron trifluoride formula BF3. You know, in ammonia there is a pair of electron on nitrogen and there is a vacant orbital in boron in BF3, vacant orbital. Now there is a chance to formation of bond. What type of bond? Coordinate covalent bond. In the formation of coordinate covalent bond, what happen? One atom can donate pair of electrons and another atom accept that pair of electrons. Okay, see here this low nitrogen, so donate pair of electrons to vacant orbital of boron and forms a dative bond, that means coordinate covalent bond between ammonia and boron. This is ammonia boron trifluoride molecule. Now why arrow towards boron? Because nitrogen donate pair of electrons to boron. Okay, so this arrow indicate coordinate covalent bond. This is coordinate bond. Coordinate covalent bond. Okay, so now tell me, according to Lewis theory, which one acid, which one base? BF3 accept pair of electrons, right, from NaH3, that's why this is acid. NaH3 donate pair of electrons to vacant orbital of boron, that's why this is base. Electron pair acceptor acid. Electron pair donor is base. Okay, and forms coordinate covalent bond between them. Okay, so in this reaction, boron trifluoride act as acid, ammonia act as base and forms ammonia boron trifluoride molecule. Okay, now one more example. Formation of ammonium ion. See how ammonium ion is formed. Ammonium ion formula NaH4 plus reaction between ammonia NH3 and H plus proton. You know, in H plus there is a vacant orbital, right? How you can say there is a vacant orbital? You know, hydrogen atomic number 1, electronic configuration 1s1, 1s1. That means one electron present in 1s orbital. Now H plus means lost that electron, right? H plus means lost that electron. So lost that electron, then vacant orbital, right? Lost this electron and vacant orbital. So H plus has one vacant orbital. As we discussed before, in ammonia, nitrogen has lone pair of electrons. Now here what happened? Nitrogen donate lone pair of electrons to vacant orbital of H plus and forms coordinate covalent bond between nitrogen and hydrogen. Now NH3, this is. Why arrow towards hydrogen? Because nitrogen donate pair of electrons to H plus. So that's why nitrogen towards hydrogen. This is the formation of NH4 plus ammonium ion. Got it? So in the formation of ammonium ion, which one acid, which one base? Which one accept pair of electron? H plus accept pair of electrons, right? That's why this is acid, Lewis acid. Which one donate pair of electrons? NH3 donate pair of electrons. That's why NH3 is base. Right? Next one. One more example. Formation of hydronium ion. How hydronium ion is formed? Hydronium ion H3O plus. H3O plus. Okay. A reaction between H2O and H plus. In H plus, just now we discussed H plus, vacant orbital, having vacant orbital. In H2O, oxygen has two lone pair of electrons. Oxygen has two lone pair of electrons. Now oxygen ready to donate pair of electrons as it contains two lone pair of electrons. H plus ready to accept pair of electrons as it contains vacant orbital. Now oxygen donate pair of electrons to H plus and forms coordinate covalent bond between hydrogen and oxygen. Okay, so this is the formation of hydronium ion, or we simply write H3O plus, hydronium ion. Okay, in the formation of hydronium ion, which one acid, which one base? H plus accept pair of electrons from water, that's why this is acid. H2O donate pair of electrons, that's why this is base. According to Lewis acid base theory, accept pair of electron acid, donate pair of electron base, and forms coordinate covalent bond between them. Got it? So this is Lewis acid base theory. Pair of electron acceptor acid, pair of electron donor base. Okay. Next one, we are going to discuss types of Lewis acids. There are different types of Lewis acids. Already we discussed definition for Lewis acid. Electron pair acceptor is Lewis acid. Okay, so there are different types of Lewis acids. First one, atoms which contain electron sextet. Electron sextet, nothing but 6 electrons in the valency shell. How many electrons in the valency shell? 6 electrons in the valency shell. Generally, what type of atoms or molecules stable? If the atom containing 8 electrons in the valency shell, that means follows octet rule, then the atom or molecule generally stable. Now atoms which contain electron sextet means 6 electrons. Oxygen containing 6 electrons in the valency shell. So to get stability, it requires 2 more electron, right? 2 more electron. That's why ready to accept pair of electron from the other substance and will get stability, because then it will contain 8 electrons in the valency shell. Oxygen 6 electrons. Now if it accepts 2 electrons from the other substance, pair of electrons from the other substance, it will become stable. Why? Because then oxygen contains 8 electrons in the valency shell, stable. Generally which follows octet rule, then the atoms or molecules are stable, right? So that's why atoms which contain electron sextet, that means 6 electrons in the valence shell, or act as Lewis acid because they are ready to accept pair of electrons and will get octet configuration, then will become stable. So that's why they accept pair of electrons, then act as Lewis acid. Okay, next one, electron deficient molecules. Electron deficient molecules nothing but less than 8 electrons around the central atom. That means do not follow octet. Less than 8 electrons. For suppose if you can see BF3 around the boron 3 bonds present. Each bond represent 2 electrons, right? So 2 electrons, 2 electrons, 2 electrons, 6 electrons around the boron. Do not follow octet. Octet means 8 electrons. So that's why boron has vacant orbital. That's why ready to accept pair of electrons and will get stable, because if it accepts pair of electrons, it will become follows octet rule. That's why it will become stable. So electron deficient molecules are Lewis acids. Why? Because they will accept pair of electrons and will get octet configuration and will become more stable. That's why. So electron deficient molecules are Lewis acids. Okay, next one, molecules. Example BF3, AlCl3, BCl3, BF2, FeCl3, SnCl2, all are electron deficient molecule, less than 8 electrons around the central atom. So all will get pair of electrons from the other substance. Next one, molecules having multiple bonds, not carbon-carbon multiple bond. CO2, C double bond O, C double bond O, multiple bond. Multiple bond means double bond, triple bond, like that between the atoms. Carbon, oxygen, double bond. SO3, multiple bond between sulfur and oxygen. Molecules with multiple bonds are act as Lewis acids. Why? Because see here, oxygen more electronegative than carbon, right? That's why this bond pair of electrons attracted by oxygen, then oxygen gets negative charge, partially negative charge, carbon gets positive charge. Positive charge. So positive charge means now around the carbon how many electrons? Tell me how many electrons? 1, 2, 3 only, not 4. Why? Because already this bonding electrons attracted by oxygen. Now around the carbon 3 bonds, 3 2s are 6. Now this is electron deficient. Just now we discussed electron deficient molecules are act as Lewis acids because they accept pair of electron, will get octet and will become more stable. So that's why here now carbon accept pair of electrons, will get octet configuration. Now around the carbon 8 electrons, but in this bonding electrons attracted by oxygen. Why? Because the oxygen more electronegative than carbon, right? Then carbon gets partially positive charge. Then around the carbon how many bonds now? 1, 2, 3 only. 3 2s are 6, less than 8 electrons. So it will accept pair of electrons from the other substance. That's why act as Lewis acid. So electron molecules having multiple bonds are act as Lewis acids. Example CO2, SO2, SO3, NO2, Cl2O7, all are having multiple bonds. Okay, next one, all simple cations are Lewis acids. Simple cations H plus, Ag plus, CO3 plus. When positive charge is formed? By loss of electrons, right? If an atom lost electrons, then vacant orbital is formed, right? Okay, for example hydrogen, electronic configuration 1s1. If it lost 1 electron, then 1s0, right? Vacant orbital. If an atom lost electrons, then form vacant orbital, right? So vacant orbital formed means ready to accept pair of electrons from the other substance, then act as Lewis acid. That's why all simple cations are Lewis acids because they are having vacant orbitals. How vacant orbitals are formed? By loss of electrons. So all are having vacant orbitals. That's why ready to accept pair of electrons. That's why all simple cations are Lewis acids. Okay, next one, molecules in which central atom can expand its octet using vacant d orbitals. Some atoms having vacant d orbitals, for example sulfur. In SF4, sulfur, you know sulfur atomic number Z is equal to 16. Electronic configuration, valence state electronic configuration 3s2 3p4 3d0, 3s2 3p4 3d0. Valence state electronic configuration 3s2 3p4 3d0. So 3d0 means all are vacant orbitals, right? Vacant orbitals. So whenever they have vacant orbitals means ready to accept pair of electrons and its octet increases. Now around the sulfur 4 bonds, 4 2s are 8 and also one lone pair also there. So and also vacant orbital, sulfur having vacant orbitals. So vacant orbitals means it is ready to accept pair of electrons from the other substance, then act as Lewis acid and its octet increases. Now sulfur, around the sulfur, for suppose silicon, you can take silicon, around the silicon 4 bonds, 4 2s are 8. If it accept pair of electrons, then around the sulfur 10. If you accept 2 pair of electrons, around the silicon 12 electrons. Expand its octet. SiF4. In SiF4, silicon tetrafluoride, around the silicon 4 bonds, 4 2s are 8 and also silicon atomic number 14, 3s2 3p2 3d0. Vacant orbitals, silicon having vacant orbitals, right? Okay, so due to having vacant orbitals, it can accept pair of electrons and act as Lewis acid. For suppose around the silicon 8 electrons now. If you accept pair of electrons, around the silicon 10 electrons. If you accept silicon 2 pair of electrons, around the silicon 12 electrons. That means expand it octet. Before 8, if it accept pair of electrons, 10. 2 pair of electrons, 12. So in which central atom can expand its octet? How it can expand octet? Due to having vacant d orbitals. So this type of molecules also called as Lewis acids, right? So these are the 5 types of Lewis acids: atoms which contain electron sextet, electron deficient molecules, molecules having multiple bonds, all simple cations. Here note one important thing: all simple cations except ammonium ion NaH4 plus and also 1A 2A group cations. 1A 2A group means lithium, sodium, potassium, rubidium, cesium. Why? Because they are already stable. Na plus stable. Why stable? Sodium 11 minus 1 10 electrons means reaches inert gas configuration. So all are reaches inert gas configuration means already stable. That's why no need to accept pair of electrons. So that's why all simple cations Lewis acids except ammonium ion, not a Lewis acid. 1A and 2A group cations not Lewis acids. Na plus, K plus, Rb plus, Be2 plus, Mg2 plus, Ca2 plus. Those are 2A group cations. These are 1A group cations. So these are not Lewis acids. Otherwise remaining all simple cations are Lewis acids. Okay, and final, molecules in which central atom can expand its octet using vacant orbitals. So having vacant orbitals ready to accept pair of electrons and expand its octet. So those type of molecules also Lewis acids. Okay.